honeybee colony presents very specific and different conditions for reproduction when compared to other livestock enterprises. The honeybee colony is a very complex family, and in this program we discuss the artificial insemination of queen bees. The fertilised queen bee has semen from drones stored in the spermatheca, the organ where the queen can store up to 7 million sperm. As in nature, a queen bee mates with many drones, but only in the first 10 days of her life. Daughters of the queen raised from fertilised eggs are sterile workers or can be virgin queens. The virgin queens are a key part of artificial insemination. The drones are the sons of the queen and are raised from unfertilised eggs. In Australia, 3 main races of honeybees are used: Italian, quick build-up, docile, good honey gatherers; Caucasian, store honey, round brood, gentle; Carnolian, winter well, good gatherers. The strain within the race determines many of the characteristics. Inseminated queens can be used in colonies to produce honey and/or pollinate crops, or be used as breeder queens to produce queens that can be open mated. Artificial insemination can be used to enhance colonies by controlled mating desirable genetic traits and maintaining them. For example, comb honey producers prefer bees that whiten the caps of honeycomb cells compared to bees that don't. Desirable genetic characteristics include honey gathering, disease resistance, and docility, and look or appearance is important to some apiarists. Hygienic behaviour is a very desirable genetic trait, as the resulting colonies have high resistance to brood disease by having healthy brood pattern. Many types of commercially available queen bee insemination instruments are available. Importantly, prior to and after each use, all equipment that comes in contact with queens or drones must be sterilised in a sterilising chamber or pressure cooker. The types of equipment you decide to use is your own personal choice. However, points to consider include quality versus price, types of syringes, shape, size and design of tips, type of hooks, sting and ventral. Tweezers can be used instead of the sting hook. Range of movement, precision of adjustment. Once you've purchased the equipment, select the stock, that is, the drone and queen stock you wish to propagate. You'll need to raise sufficient numbers of drones to supply the semen, which you will also be collecting. The drones to supply the semen need to be mature. Drones mature at 16 days of age, and the semen available will depend on the age, nutrition, and care of the drones. Each mature drone can provide up to 1 microlitre of semen. The selected drones are collected from the desirable hive or hives from above the queen excluder and placed into a drone holding cage for transporting to the inseminating room. It's very important to have sufficient drones, up to 30 on hand, as many may not be suitable for a number of reasons. Once in the insemination room, the drones are placed into a small flight cage, then caught. Each drone is held between your thumb and finger to put pressure on the tip of the abdomen to cause partial eversion. Then roll your thumb and finger along the drone's abdomen to cause full eversion to expose the semen. Eversion process. Avoid contamination. Pressure the abdomen tip, then pressure the abdomen side. Eversion will occur, exposing the semen. Care is then required to collect the semen using a syringe. Hold the drone with the exposed semen and with the syringe just touching the exposed semen. Skim the semen into the syringe, being very careful not to draw up any mucus. Use a saline solution to prevent drying out. Semen collection. Maintain airspace, skim semen, avoid air bubbles, avoid collecting mucus. Collecting saline solution to prevent drying out. Insemination. Collect the suitable aged virgin queen from the holding nucleus hive when about 5 days old and no longer than 10 days of age. Place her into the backup tube head first, then into the queen holder. The assembly is then connected to the carbon dioxide cylinder using tubes. Turn the CO2 flow onto 2 bubbles per second to anaesthetise the queen. Looking through a stereo microscope, the ventral hook is then attached to the queen's protruding abdomen on the left side. The ventral hook is a holding hook. Tweezers are then used to lift the sting, then allow a passage for the tip holding the semen to be manipulated very carefully past the queen's valve fold into her medium oviduct, providing all the angles are correct. When the tip is in place, the semen can be inseminated into the queen using 8 microlitres in a measured dose. A sting hook can be used instead of tweezers. Once completed, the tip is removed from the queen, hook and tweezers removed, and the CO2 turned off. The queen is removed from the queen holding assembly at this stage. Remember, it's important to clip the queen's wing and mark the queen using an identification tag and record the genetic details for future reference. The queen can then be placed into a queen cage to introduce back into the nucleus colony and the nucleus identified back to that queen. Inseminating semen, CO2 at 2 bubbles per second, maintain correct angles, lift the sting structure, position the tip correctly, bypass the valve fold, prime tip with saline solution, measure semen dosage. To stimulate laying, the inseminated queen is removed from the nucleus hive 24 hours later and exposed to carbon dioxide again in a plastic bag. Within 10 days, check that the inseminated queen is laying, and again within 3 weeks to ensure normal brood is present. This will indicate a successful insemination. Inseminated queens will lay for 2 to 3 years and, if kept in small colonies, up to 4 years. Good value from selected artificial insemination as a means of improving the health and productivity of honeybee colonies.